Okay, so hello everybody. I'm gonna start. So I'm very happy that so many decided to have their post-lunch nap in this talk about test-driven architecture. So yeah, just lean back, relax. I'm gonna hack away most of the talk probably. Okay, so this basically is about automated tests of static architecture in Java projects. So about me, who am I? My name is Peter Gafert. I'm from Germany. I work as a principal consultant for a company called TNG Technology Consulting. And part of us does nice greenfield projects with like fancy things like AI and machine learning. But another part works more on the dark side and has to do brownfield projects like those nice big projects that evolved over time, and now maybe they have like a little bit of trouble because their architecture kind of deteriorated in time. So this is like a little where I come from. So I would call myself like an everyday agile architect. So I mainly work in some sort of scale Scrum process. Like at the moment, it's I don't know, like 60 developers and 10 teams that are just like hammering features into this one big monolith with like 5 million lines of code or something like that. And the question is if everybody has like this short-term scope, right? So every team thinks like, oh, 2 weeks, I committed these features, I'm gonna get them in no matter what. How do we keep this big Friday to go the right way and like keep the architecture maintainable in time? Because otherwise we might end up with like some big ball of mud, everything depends on everything, and it gets really like, we get really slow. So we don't want like a curve like this and we get like slower and slower because somehow you cannot really modify anything anymore and extend nothing. So yeah, this is a little bit the challenge if so many people work on the same thing. So the way I know it is this software architect is more like a role and like different people might share it. It's not like the ivory tower architect who just like sits in his room, draws like nice concepts and then throws them down to the developers and say have fun, and the developers say like, oh, damn it, this doesn't match at all, and like how are we gonna it's gonna take like twice as long. So I think you always should eat your own dog food as an architect. So if you say this is a good concept to keep this maintainable, then you should also implement code yourself and like see if this really feels good. And if not, you should do iterations and adjust your concepts. And also we don't want the concepts to go a completely different way, right? So we don't want like say, oh, it is like this, we have a layered architecture, but anybody who looks into the code will see like, what? So it's like completely different. Okay, so to deal with this task, if everybody just shoots away on like a common code base and maybe with different understanding, and there's like people coming and going, like a couple of years ago, I found it really difficult to achieve like automated tests of all our concepts with free tools. So that's why I created this library ArcUnit, which is what I'm going to show you today. It's like where you can just write plain JUnit tests, for example, and in those JUnit tests, you can test your programming. So it's like a meta programming. So you can write a test about your code that it behaves in a certain way. Okay, this is all static, all bytecode analysis. As a motivation, I brought some history of releases of two common libraries. One is Google Guava and one is Hibernate Core, simply because I think many developers know those libraries. They're very, very widely used. And I just thought I would start to plot the release artifacts. So I started to download these jar files from Maven Central and started to plot the top level packages and see like what they consist of. So like the original Guava R03, like the oldest one I could find, pretty much looks like this. So it has like a little bit about collection schemes, a little bit about primitives, a little bit about I/O. There's like some base that everybody likes a lot. And then it started to evolve, right? So we have like different releases, and we see like, okay, new stuff is popping up. So 10.0 had like something new like caching and event bus. But if we look at this, there's something we can notice, and that's like it's always a directed graph, right? There's no cycles. Also, it kind of makes sense if we look at how stable these things probably should be, right? So base probably has like some really core functionality that does not change too often. So it is not, if this is stable, it's not so bad that everybody depends on it. If this wants to evolve, then this is a different chapter. So event bus has nobody who depends on it, so it can evolve pretty freely, for example. Okay, and then just goes on, and like new subdomains pop up, like reflection, net support, like some escape utilities, and yeah. So, and if you look at the last one that I plotted, which was kind of recent, it looks like this. I hope this is somewhat possible to read this. We had a little trouble to adjust the slides to full HD, so if something doesn't look completely nice, then I hope you forgive me. I tried to like fix it right before, in a couple of minutes before the talk. Okay, but it still looks good. So every single release, we had like the same properties, right? It was always a directed graph. It was always kind of this, the more stable ones in the center. Okay. So if we compare this with Hibernate, if you plot the top-level packages, this looks kind of different. Huh? So let's check it out. Okay, so I don't know. What we can see is it has a different shape, right? It's kind of round, so because you cannot really find anything, any package that has only outgoing or only incoming dependencies, and you can find stuff like this. So maybe my plot was not fair, maybe it was never meant like this, but if you do take the top-level packages under Hibernate Core, then this is what you get. Yeah, I don't know. So the problem is, if you look at this, if you work up here, it's in Event Bus, it's pretty clear that it's easy, right? So you know that if you work up there, you're probably not going to destroy some logic about primitives or base down here. If you had a dependency from base to event bus, you would pretty much be in hell, right? Because then you could like edit event bus, modify base, everybody depends on base, so you can kind of affect everybody. Okay, oops, but Hibernate, so if you go on like the 4.0, I know you cannot really see it that well, but it pretty much just stays like this, right? So it did not get better in time. Okay. So what can we learn? Obviously, you can have a lot of package cycles and your library is still like widely successful, so you don't have to die just because of that. I would claim it's probably a little easier to get into a scenario like this because it's just clear what I affect, what affects me and what I affect, while here like it's kind of, I don't know, no matter what I touch, I kind of affect everything, maybe, I don't know. Also, I would claim that this here is like the natural thing. If you just, if you tell like 20 developers, go here and implement these complex features in a complex domain, go for it, you probably end up with this if there's no other restraints. So you just need enough people with different sorts of looking at things, and like it will just like go this way. I would claim it does not go this way by itself. Also, I mean, I have no idea how the Guava library was developed, but I did find some sort of whitelist circle file. So I would claim they probably had some automated testing here that kept it like this and did not go like anyway. Okay. So what I'm going to show is pretty much how to use ArcUnit. So this is where coding already starts, which can help to prevent something like these everything depends on everything, or we get very inconsistent structures, and every team goes its own way. So I have like a simple example project I always use is like an old Spring workshop. It's some sort of instant messaging thing, only the backend, where like some users with profiles can send messages to their contacts, and there's a couple of other subdomains just to show Spring features. And I'm going to start here in this example test, and I'll show you how you could use ArcUnit to test properties of this code base. So what do you have to do to add this? It's pretty easy. So I'm using the JUnit 5 support, which means I have two different dependencies here. It's like JUnit Jupyter, where you have an API in compile scope and an engine in runtime scope. If you would use JUnit 4 support or just the plain ArcUnit library that does not depend on any test framework, it would only be one dependency. But you just add this dependency, and then you can you pretty much are ready to go. And you have like a core entry point called class file importer, which surprisingly imports class files, which offers a lot of different methods. So you don't need to have these classes on the class path. You can just say, I want my workspace somewhere, some folder, and it will like take all the Java classes, the bytecode, import that, and give you a lot of information about this code. But you could also say, I want to live in the context of my current project. I'm going to use the class path, those classes that are on there. And for example, I want to import the package of some class. So I'm going to choose this class because it's just, it's just a top-level class, right? So I know this is the central Spring configuration, which will always mark the root of my project. So this is a good way to go. So if I choose this to rename it to demo2, everything's still fine. I don't need to worry about stringly typed packages. Okay. So, and if we do this, we get something back, namely some Java classes. An object, which is pretty much just an iterable of Java class. So we can look at a single Java class if we want. For example, if we take here a simple Hibernate entity, class user, which just has a couple of properties, first name, last name, so it's like a simple Pojo. And we could say we want to get this user class here. So what we get is a Java class. And for anybody who knows reflection, this is pretty straightforward. So if we do reflection, we can check out the simple name or the fully qualified class name of some class object in Java. Package name, we can look at the methods or the fields, right? And the Java class we get here pretty much has the same. Yeah, we have name, methods, and so on. So if you know reflection, this should feel kind of familiar, but this would be a little lame if that was all, right? So the advantage here is that you have a lot more information. So because this takes the whole context into account, and it looks into the bytecode and says like, gives you information about the relationship between classes. So I could, for example, say what subclasses does this class have, which would not be possible with reflection. Or I could say, what method calls do I have? Yeah, what methods does this class call? So this would normally not be possible. So let's see what methods this class calls, and we could do see. So every method call we get, we write this out and see what happens. So okay, and we get like a fair share of details down here. So the description is pretty much like a nicely readable description. So it says like the method set incoming contacts, for example, as a user set incoming contacts, calls the method Java util list clear. And it even gives me the line number, 77, and IntelliJ is even nice enough to make this a hyperlink, so I can click and I see like, oh, okay, this is the method set incoming contacts, and in line 77, on a Java util list, it calls the method clear, right? So that's pretty neat because we can use exactly this information to check if our architecture is still not violated. Okay. So I mean, typically I could even just use that and start to do something like this, right? So I take all the classes, I filter them. For example, I want the classes that are services, however that's determined in my project. So let's say services just reside in a package service, controllers just reside in a package controller. So maybe I would say I filter all classes that reside in service, and I want those classes to be only accessed by the classes that reside in a package controller. So I could just write this down like this, but I wouldn't really convey too much semantics what my intention was, right? Maybe, I mean, I could give it a good name, but still, So what ArcUnit does is give you a very concise way to do this. There's like an arc rule definition, which is kind of an entry point to some syntax. So let's see, what was this offer? So I said I want something like the classes that reside in the package service should only be accessed by the classes that reside in the package controller. So, and I can just write this pretty much, because the API supports exactly that case. So I take classes, I limit them to a subset I'm interested in, and I assert something about the subset. So let's take the classes that reside in a package service. So here we need to know one thing. This is like aspect J, so 2 dots means any amount of packages. So we find any package that has some sub-package service in there. Doesn't matter if it's foo.service.bar or bar.service, so all those packages we get, right? So this is what we're interested in. And then we should say, what should this satisfy? So it should, for example, only have dependent classes, so classes that depend on those classes that reside in a package controller or in a package service, because otherwise this would be pretty boring, right? So if I cannot access myself, okay. So let's see, we get something of type arc rule. So this is an architecture rule that we can now use. So we can now say, I want to check this rule on the imported classes. Okay. It's pretty neat because you kind of can read this like plain text. Also, okay, not satisfied, right? Let's see. I wish this was a little. Okay, so I hope this is still, you can read this, right? If I should make it too small, just yell at me. Okay, so what we also get immediately is like a nice message, right? So the API just uses this up here to give you a message about what the rules should be. You could override the message, but by default, it's just what you write in code will be the message here. So classes that reside in a package service should only have dependent classes that reside in a package controller service. Okay, and then we get like all the details. So it was violated 23 times. For example, because we have something here like called audit event notifier, which is not a controller and not a service. So it might be okay to have that, but we lied when we said we only have controllers that access services, right? So now at this point, we have to be conscious and say like, oh, okay, actually this is okay too. So actually the rule is either controller or administration, or we have to figure out what is this here, right? We also have something like this, an integration test that resides in integration kind of violates this rule too, but that's maybe no problem, right? Because so maybe maybe we should just test our main code. So I will show you how to do that. So we can pretty much add an import option, which is just a predicate that says like what sort of location, what sort of URI do I want. So I could do something like this, right? So this is like file URL, so I have file : / my workspace, Maven target classes or something like that. So I could say if there's test in there or test classes, then skip those classes, right? So I'm not interested in those. But since this is so common, this is already predefined, so I can just say I want the predefined option do not include tests. And this is like kind of adjusted so it would work with Maven and Gradle. If it does not match for you, you have to implement this interface in here yourself. Okay, and then we have like only 7 violations and not like before 35. And it's only like this administration stuff here that we should think about. Okay, so but what we see here is there's kind of boilerplate involved, right? So if I have like 10 or 20 of these tests, then I probably want to cache these classes somehow, because why would I import them every time again? And if it's like 50,000 classes, then this will take some time, right? It will take like 30 seconds or maybe 60 seconds even, if it's sufficiently many classes. And I really don't want to do this for every test. And also down here, I don't really want to be able to forget this, because it's very unlikely that I write a rule and then I don't want to check it. So this is where the JUnit support comes in. So with JUnit 5, you could just, JUnit 4 looks almost the same, you just need one further line. But you can just, the stuff we had down here, this part, we can just declare this up here, right? So we say we want the packages of workshop configuration, and our import option is do not include tests. Huh? Okay. This must be a class because it's an annotation. So this is pretty much an instance of this type. Okay, once we have that, we can write ArcUnit's own annotation here. We can just write, this is an arc rule demo. And this here, we don't want that either, right? So, okay. Now we have like the bare minimum that's really interesting. Huh? So what we really want is just write down a list of rules that our code should apply to, adhere to. Okay, and we see like same 7 violations, right? Okay. Since the last release, there's also like an extended API for members. I'm just gonna show that real quick. So you could also, this is an example from Twitter actually. You could also say I wanna write a rule about my fields. And I could say I don't want to use field injection, for example, so I can say fields should not be annotated with auto-wired, for example, for Spring. And this is pretty easy, right? So, I mean, everybody knows. I could even be fair to people, why am I doing this? Because we want, or we prefer constructor injection, yeah? Okay, oops. Okay. So now anybody who reads this message will get like a nice message right here. So it's kind of clear, okay, fields should not be annotated with auto-wired because we prefer constructor injection. And we get a long list of fields that violate this rule because I did not stick to that rule. Okay. So yeah, but we could do members or methods or constructors here too. It's pretty concise to write tests about this. Okay. So what if you want to do something more complex? You can also, you can also just write a method that takes the Java classes that are cached as an argument, and then do something with that. You could, for example, do something like this. I have to disappoint you. This is work in progress. It's not in the current release, so if you like this, you have to wait for the next release, because I'm not completely sure how the API should look. But we could say we want to create a diagram of the sub-packages of demo. Oops. And then check that out. Okay. So, for example, so let's just drop this in a plant UML file and we'll have some nice oops. Oh man. More space. Okay. So how does this look? Pretty much like this, huh? So this is our structure. It doesn't look too nice either. In particular, this here was probably not as intended. So I'm going to show you how to do it the other way around. If you want to use a diagram like this, because it's very clear what's intended, and you want to use that as a rule, I'm going to show that real quick. So I'm just going to slim it down to make it like a little easier to understand. Let's see. Oh, what did I do? No. Okay. Okay, let's say this is also boring. Okay, let's just stick to this, like 5 packages, pretty easy. So if we want to use this as an input for tests and say like our classes should adhere to this plant UML diagram, then we somehow need to tell ArcUnit how these components are defined, right? So what does it mean, a component messages? How do you find the classes that are in this component? So I'm just gonna go for it like this. So we need to define how to identify those components. So let's just see. So I'm gonna write these up here. Oops. And now I can use the stereotype to say like, how can you find those, right? That you can find them by this package. It's pretty easy. So now I could also say, make these like this. And we have like a nice diagram that says like, the component messages, you can find them by all packages that contain a subpackage messages. The component contacts by this. If we go back here, then we could say, we want this resource, the diagram we just chose, and then we can start to do a rule, and we can just write classes should adhere to plant UML diagram. This is like a library function. So, oops, thank you. So it resides like in this independent top-level folder library, and we want to use this URL, and we also have to tell the API something about how it should treat dependencies. Because our classes that we look at, they probably have a lot of dependencies, like they might depend on Java long object and stuff like that. So the question is, do I want to force that all these dependencies are in the diagram? It's probably a little overwhelming because I don't want to see classes from the JDK in my diagram and stuff. So I'm going to go for, I'm only interested in the dependencies in a package, in my package, right? So, okay. Okay. Could actually, is this still okay? So, okay. So, one more thing I have to do is like, so I can't forget any classes. All the classes have to be in the diagram that I look here. So if I import the package of workshop configuration, all the imported classes must somehow appear in this diagram. Or it will throw an exception. So I did like cheat a little bit and create something like this, relevant packages. So I'll just restrict the classes to those packages. Okay. Okay. And now I see there's like one violation. And this is pretty much how this treating of dependency work, right? So I have a profile service in the profiles component, and it depends on the legacy component, and the legacy component is not in the diagram. So, but since I look at all dependencies in the package demo, it will like throw me a violation. I could say I'm only interested in the dependencies in the diagram, so only look at the ones that also are in the diagram, and then this is green because legacy is not in there, so ignore it. Okay, so but now I could go forward and say like, this doesn't look that good, right? So I think these dependencies here are not really what I want, right? So technical infrastructure, I don't really want that to depend on profiles and users and stuff. So now it looks nicer, like the Guava library, but now also the test is not green anymore, right? So, but I could start to fix it now. I see like, okay, there's like 15 violations of this diagram up here. So let's go forward and start to fix it. And if we look at that, this also really is somehow smelly, right? So we have an abstract service in infrastructure, and that abstract service knows something about the of each subdomain, kind of, like it knows about profiles and users. So this is probably a bad idea. We did not really want that. Nevertheless, this is not that, it can happen easily, right? Because my IDE is so nice, it offers me something like this, right? So what if I work on users or on contexts and I think like, oh, this is like ugly boilerplate. It's just like technical thing, like get from a repository or something, get me the thing with the ID or throw an exception. So I just refactor it, I quickly pull it up and it's gone. So nice, my code is now like so much neater in contact service, but I also coupled like every other subdomain on contact, which is really bad. And then like my instinct for consistency kicks in, right? And I think like, oh, I have the same in user, so I pull it up too, so it's consistent. And in the end, it is consistent, but bad. So, okay. Neat. So I'll crank it up one little bit more. Okay, so this is like one way to do it, right? So we have like this one central diagram. If teams start to create like a new subdomain, for example, we need like a history of messages or something. So we create a new package history on top and we add the subdomain logic of history. Then you have to adjust this diagram, right? And like add the component, otherwise it won't work. So what I'm going to show in the end is like how to kind of lay out a more abstract net of rules. So like describe your architecture and then let teams move freely within that architecture. So I'm going to go a little bit more in detail what I mean by that. Okay, so let's see. Let's go back to a method so we can do a little more. Also, I have a little cheat here. So what I have is some package info classes. So what does that mean? I could say like to my teams. So if they want to add a new subdomain or like a new module, they should add a top-level package info, and they should annotate the package info, for example. I mean, I could make this any class, but package info would be a nice thing because I can also describe the subdomain and stuff. And I say also you add this annotation, and this annotation just has like what name has the module and what's the allowed dependencies. This is a little bit like copying something like a similar thing like Jigsaw, but if you're on JDK 8, you can easily add that too and start to slowly migrate in the right direction already. So this is like independent of which JDK version. It even works with JDK 7 if you're on that still, like some people I heard of. Okay. So, okay, we have these descriptors, right? So I added one to users, I added one to profiles, and they all say like, hey, I'm the module profiles, and my dependencies are infrastructure and users. Okay. So let's see. So what if we want to get these descriptors? That's pretty easy. So we could say we want the classes annotated with module class, okay? So this, I call this my module descriptors. And that's what I meant. It does not have to be package info.class, like class files of the package info. It could be any classes. Huh? Doesn't matter. Okay, this is easy. I'm also going to show you a more advanced function real quick. This is also a library function like the plant_uml thing. The idea is pretty much you take your code base and you slice the code base by subdomain. So I want to create one slice contacts, one slice users, one slice messages, and I want to say something about those, right? So an easy way, a quick way to do this, if you have a consistent structure like this, you could say I want the slices that match the first subpackage of demo, for example. Because the first subpackage is exactly those here. Okay. And then you can say, what should they do? And at the moment, there's these two things. If you cannot think of anything other cool, just open an issue or pull request. So I could say maybe they should not depend on each other, like they are, for example, I have like an onion architecture or something, and these are my adapters, and the adapters should be independent of each other. Or I could say they should be free of cycles, because that's just never a good idea. Okay. So I could check my classes here, right? I don't need these descriptors yet. I'm going to show you in a second what we need these for, but this already works somewhat. Huh? So I check, are they free of cycles? No, I mean, it's pretty clear because we saw the diagram, right? The diagram did not look good. It was not free of cycles. So I found 7 cycles in here. For example, from slice contacts to infrastructure and back to contacts. Okay. And then I could look at the dependencies. So what dependencies does the slice contacts have on infrastructure and vice versa? Okay, so what am I going to do if my project is not that simple and doesn't have this simple structure, right? So this is where these module descriptors come in. So I could just say, like, these can be anywhere, but one of those module descriptors, one of those package infos annotated with add module, will always mark the root of a module, no matter where it is. And I could use here something more complex. There's something, a slice assignment. This is pretty much just a map where you just say, like, the class foo is in the module foobar, the class bar is in. So you just assign a string to various classes. If they have the same string, basically, they're in one slice. So this is very free. I cheated a little because so little time. So I already added that. Okay, so let's see. The modules of module descriptors. This is not really rocket science if you look at it. So what I was it has like this this signature, right? So take the, okay. Okay, so this is the signature I told you about, like a Java class. I have to tell which slice identifier, which slice it goes to. If they have the same slice identifier, 2 classes, they end up in the same slice. So what I just do is, like, I take these module descriptors I go over all of them. If the class in question here is in the package of the module descriptor, it gets the module name as the slice identifier. Yeah? If it's not in the package or in no package of any module descriptor, it will just be ignored. Okay, so it's just like 6 lines of code, so not super bad. I'm gonna add this. I make this easy in the future to just do this without writing too much custom code. So this is more like a work in progress. If you have any ideas, I'm very open for feedback and like ideas how to make it better or easier. Next version probably has this out of the box, so you don't have to write any code yourself. Okay, and now we have 5 violations, 5 cycles, because we're only looking at those 5 modules, right? Okay. This is cool, but so this would be one good rule for our modules, right? Our modules should never have cyclic dependencies, but we could write like a whole, I told you about a net, right? So we need like many different rules to lay out how it should be. Yeah? They should be free of cycles, but they should also, I can plug in a custom condition here, which says like pretty much about every of these objects, like every slice, I say, is it okay or is it not okay? So I did cheat again. But I'm going to show you what's going on here, right? So the slices assigned from these module descriptors should also respect the allowed dependencies. This is pretty much so that if I want to, let's see, if I'm in profile, I should only depend on these 2 modules, right? So I need a little bit more code, or the reason this is not straightforward is because first I need to kind of look at all the modules and the classes they contain, and then in a second run I can resolve like, okay, this module infrastructure, now I know it, I can create the link. Okay, so this is why this is not like, this is like 60 lines of code at the moment together with the other thing I showed you before. Yeah. So, but what it does is just, it takes one of those slices, like my module, it looks at all the dependencies from this slice, and basically just says, if the allowed dependencies don't contain all the target classes of my slice, then each of these dependencies is an evil violation. So, and then I can run these again. So at the moment, we have like the same like violation again because we depend on legacy, and legacy is not declared. So we also see that this is, if we create a rule like this, it's kind of a spreading pattern. So once I want to use something, I have to like make it draw it into and make it a module too. So if I lay out these rules correctly, it will like grow by itself and everything will be included. Okay, so let's see, but also just to show you this works, this only violation, we only have one violation because I added this here, which is like kind of stupid, right? So I said the module infrastructure has allowed dependencies on all those subdomains, which I don't really want. So if I throw these out, then I have like the same effect than before. So it will get like but I have like 16 violations again, right? So all those classes that are in the infrastructure slice, if they depend on contact or message or user, then I will get a violation again, and can be done here. It's like the same as before. Okay, but I can create a lot more things here. So I could also write my own condition here and say, for example, should only be accessed through an API package or something like this, right? So I say like, whenever you want to access me, please do it through an API package because this is our convention, for example. I mean, it could be a lot of different things. And then I would just start to do like, say like, okay, so I take the dependencies to my current slice, gonna stream those, and I'll filter the dependencies where the target class, which is in my own slice, if the name contains API, the full qualified name, yeah. So the ones where this is not the case, so the dependencies where the target is not in an API package are the evil ones. So I could say, for each to these events, I add a condition violated, oops, and I say, oops, oh man. I wish I could always program with such a resolution. It's okay, so okay. So I would find all the dependencies to myself where the target within myself does not contain an API package. This has like a lot of violations now because I never stuck to that convention, or not. Because, I don't know. Before I run out of time, I'm just gonna cheat. Okay. So I have a lot of violations because classes, there's a lot of classes that access me, but they don't go through an API package, for example. So this is just, yeah, so I could just write a lot of custom, like my own rules and say like our application should adhere to this, right? Modules should not have cycles. Modules should declare their dependencies. If you want to access a class, it must be in a module too, so it grows. If you want to access a module, it must be through an API package or through an interface or through a class annotated with something or whatever, right? So I can assert a lot of things there. Yeah, so this is pretty much it for that. So I've written down like some key takeaways for like the quick start. Oh, okay. Yeah, okay. Yeah, we saw that all. So if you wanna try that, just add like a simple dependency or maybe two for the JUnit5 support if you want that. You can immediately get started and write like a simple test with the class file importer, play around, look at all the information you get and what you could do with it. You can use the JUnit support to just like really concisely just write a list of your rules, and it will check it all automatically and be really fast and cache the classes between the runs. And there's like a growing number of library functions, like the slices should be free of cycles. There's also something about layered architecture, where you can just write, I have the layer controller, the layer service, the layer persistence, and they should access each other in a certain way. And you can write this very concisely, yeah, or the plant UML support. Yeah, in the future there will be more and more features down there. Yeah, so if you want to try it, there's the website artunit.org. It has a pretty extensive user guide. If the user guide sucks, tell me. Open an issue. I'll try my best to improve it. I think it's not too bad, though. It tells you everything about how to get started at the dependency. It gives you some inspiration what you could test, and it gives you a lot of gory details, like how the domain model of ArcUnit itself is composed, like the Java classes, Java methods, stuff like this, and advanced configuration in parts. Yeah, you can follow ArcUnit with the handle arctests because ArcUnit was taken. That's pretty much it. So if you have any questions, feel free.
Hello. Thank you for the presentation. A couple of questions. Usually when we are talking about the architecture and we usually develop not only one application and developing system that consists of many applications, is there any way or any highlights how we can, let's say, use your tool to test the dependencies of components in the system? So, for example, I have a core library that may be used in different other components, and I definitely would like that this core library is used in a proper way. For example, I have a contract that should not be validated, but I have only one component, for example, Maven project that I can test with your tool, but how to test it with other companies?
You mean if you can distribute those rules and use them in different places?
Yes.
Or,
for example, we can even implement some core libraries, and these libraries will be used by other teams that develop the same system.
Yeah. Let's just see. You could. One thing you can do is just create a simple dependency, right? So you could say arg rule. So I'll just add something stupid. So I write down like the core rules that I need, that I want to have everywhere. And in my other project, for example, I could say I publish this char artifact to my Maven repository or something in my company. And somewhere else I could just use this in another class. And I could, for example, say, could just include it here, say like, oops. I could include it like this. I could say it's the example test. So I want all the tests. I want to have all the tests in example test. And then if I run this test, it will like evaluate all the rules in there. So I could say, I could build a hierarchy. So at least that's how we do it in my project. So we just, we publish an artifact with our core rules, our rules. And then in other places, we would just say, I want to check all the rules in my core library. This is one way to publish it. Okay. Maybe I did not understand the question.
Thanks. I think in some order it answered the question. And one more question related to, let's say, set of best practices. Looks like during the implementation of this tool, you definitely were thinking about the common practices or best practices that should be used in the application. For example, we should not have so-called dependencies between packages. Is there any set that we can just incorporate into the application and check whether it complies to the best practices or not?
You mean like, do you mean your own rules or
no, I mean
predefined rules that are always good practice?
I mean set of rules that we can use out of the box to check.
There's a couple of rules, right? So if you have a good other idea, I'm open for pull requests. There is like coding rules, though, I think. General coding rules, for example. So this has pretty much something like no classes should access standard streams. So if you write to system out, that's probably not a good idea, something like this. It's only a little set, though. There is, meanwhile, a Maven plugin, which is not from me, but from a different implementer. You can find that on the website of ArcUnit, and they have like some rules they share too. But I mean, I think mostly it's very different for every project. So I don't know if there's so many generic rules you could always apply. I think this is a pretty common one, or that you should not use Java util login. But at the moment, it's only like these four, right? So maybe you don't want to use Yoda time anymore, Joda time, because you're Java 8 or something like this.
Okay, thank you.
Hi, this is a great library. I have a question. If I have a project that intermingles Java and Groovy classes, for example, could I use something like this for both?
Of course, you had to say Groovy, right? So if you say Kotlin, easy. The problem is about the bytecode, right? So if you have the information in the bytecode, you're fine. So if you do Groovy with compile static, maybe you have it. Otherwise, all the information you can pull out of Groovy bytecode is like, oh yeah, I use some default Groovy method that goes like magically somewhere, and I don't know. So Java's easy, Kotlin's easy, Scala would work too, I guess. Have not tried it, but you all have like a lot of information in the compile classes there. But Groovy, I know that if you just use dynamic Groovy, it's like the curse of every dynamic language. You probably need like source code analysis kind of for that, I would think, and not bytecode.
One of the main benefits of, say, microservice architecture is its aggressive modularity, right? That's one of the main things. You are essentially proposing an alternative to that, at least as I understand that. How long can this keep a project clean? Does this mean that in the cases where we would be doing microservices for their modularity, this is a long-run alternative?
So for microservices, what you can do is you could say like, even though we have many microservices in our company, they should all have a certain consistency. They should be composed maybe similar. But of course, with the dependencies, you have no chance. If there are dynamic dependencies...
This was not really the question. I can use this to avoid having to do microservices, right?
Yeah, so this core argument in the beginning where the microservice hype was created was pretty much, finally we have to think about our dependencies and cannot bypass the API, right? So if this is your only reason to do microservices, I would really urge you to consider if it's not smarter to maybe keep it together because you have more ways to analyze it, and then keep it like a clean monolith for the beginning, because as soon as you distribute it, you get a lot of other problems, right? So if you do it well, fine. If you are a big company and you have like your huge monolith, instead of ripping it apart, you could start to do like this, try to get it like a modular monolith, where you have like clear dependencies, and if you need to, you can easily pull it out and distribute it separately, and then you can scale it up or whatever you need from microservices. But just for this architecture view, maybe you don't need microservices to...
So in your mind, this is a long-run solution for a project. This will keep the project clean for years.
I would say it depends on your use case. I just think with microservice, you need to be pretty careful, because I heard a lot of bad stories, like everybody said for a while, microservices is the way to go, the best thing. Microservice, nanoservice goes super small, and then they have like 200 microservices that need to be started in exactly this order, or everything will break, and like one single microservice fails and it's gone. So then you don't really win anything. So you get a lot of challenges, and maybe the benefits are not that big. So I think you can keep it clean that way too. So you could say I have a couple of I want some microservices, but maybe they're like not super micro, right? So I always put a couple of domains together, I check them like this. I say like this is like a micro monolith, and it has like a clear structure, and it stays clean. So if I really need to, I can pull something out, because my dependencies are very well structured, right? So if I need to pull this out, like in Guava Event Bus, it's easy to pull it out, because nobody else depends on it. So I just have the options. I just keep the options open, and if I need to, I take it apart, and it's easy then. So the biggest pain I always had was if there's no checks like this, and then once you try to pull it out, it's like catastrophe, because you're like completely entangled, and yeah.
Thank you.
Thanks for your talk. I have a question. How well is this framework is aligned? Oh,
Where
I'm
you?
here.
Oh, okay. Okay,
How
so-
well your framework is aligned with Project Jigsaw?
It's pretty independent of that at the moment, because I come from like an old, I mean, there's like a lot of old applications. So every time I see like questions like, who's already on Java 9, yeah? So this is long out. And like last time I saw this question at a Java conference, it was like 60% about we're still on JDK 8. So you can do this independently of the JDK, right? So, but it does not have at the moment specific support for module info or something like this. It could be added because in the core it uses the ASM bytecode library, and that one would support the module info classes too. So I could look at the Jigsaw information too, but so far nobody wanted it. Okay, so yeah, if you use Jigsaw, maybe you don't need to add custom module support. Maybe you just want to keep a consistent structure, or like stuff like the access to my modules should be through a certain way, to like through classes that are annotated with something. It's important, or they implement an interface or an API package, or don't know. So,
Well, thank you.
okay.